In this video, we're going to take a look at how we can use a formula with logs in it in order to uh, compare earthquakes. So on this one, notice we have an equation where the magnitude of an earthquake is the log of the seismic wave of the earthquake divided by an initial just standard wavelength. So on that, what we're going to do is we actually don't need to care what W sub 0 is. It's going to end up going away. But we do, and we don't really totally need to know what W is. But when we compare them, we're going to name W based on the earthquake. So we're going to be comparing an earthquake in California in 1989 that was a 7.1, and we want to know how many times larger the wave there was than the March 2005 earthquake off the coast of Sumatra. So we want to know how many times larger the 2005 earthquake was than the 1989 instead of the other way around. So the number of times larger, you can do that by taking the bigger one and dividing it by the smaller one. So I'm going to name these based on the wavelengths based on where they were at. So the California one is going to have a wavelength of WC. And the Sumatra one's going to have one that's a WS. To know how many times larger the wave of the bigger one was than the other one, what we need to look for is WS divided by WC. It doesn't actually matter what they are. We just need to find this expression right here. Now we can do that with our logs because if you remember, when you subtract logs, you end up doing division. And when you do division of fractions, the second fraction will flip and multiply. So we can kind of use that to our advantage with this formula. What we're going to end up doing is we're going to end up subtracting the equation for each of the two logs. And in turn, we're going to end up finding this expression right here. So we're going to go ahead and plug in what we know for each earthquake. So your California one, the magnitude of that was a 7.1. And that's going to equal the log of the California one over this standard log, or standard wavelength. For the other one, we have 8.7 equals the log of its wavelength divided by the standard one. Now, we need to know how many times larger the bigger one was. So what we're going to do is subtract these two equations. We're going to take the bigger one here, the 8.7, and subtract the 7.1 on that side of the equation. And on the other side of the equation, we're going to take its log expression and subtract the other log expression. What that looks like is 8.7 minus 7.1 on the left side of the equations equals the log of our bigger wavelength divided by the standard minus the log of the smaller one. Now, when we subtract the logs, if you remember, we can go ahead and condense those. I'm going to erase this so I have a little more room on this side. And so when we subtract them, when we condense them, they turn into division. So what's going to happen with this expression right here is we're going to end up with log, I'm going to do it over here to simplify it so you can see what's happening, log of, whoops, I want to move that back up there, the WS over W sub 0, and that is going to be divided by WC divided by W0. Now, oops, when we do that, the bottom one's going to flip and multiply. So this is going to turn into the log of WS divided by W0 times W0 over WC. So notice that now the W zeros cancel. And what we're left with is the log of WS over WC. So that's what this side of this expression ends up being. Now on the other side, we can go ahead and just subtract the two numbers. So 8.7 minus 7.1 ends up being 1.6. And that's going to equal what we just came up with here, which is log of WS divided by WC. Now we want to know what WS divided by WC is because that will tell us how many times larger the other one is. Now, it doesn't seem like 8.7 is very much larger than 7.1, but in terms of magnitude and how big that earthquake really is compared to the 7.1, which is still a big one, there's a huge difference, and you'll see why in a minute. It's because this log is base 10. So when we switch out of log form in order to get that expression, we have 10 to the 1.6 equals the stuff inside, which is WS over WC. So we need to do 10 to the 1.6 in our calculator to get how many times larger. And what we come up with is that this expression here is going to be equal to 39, I don't have much room, so we're going to move it down here, 39.8 times larger. So the division of those two, which is how many times larger the bigger one is 39.8. Now 39.8 times larger is a lot bigger, even though we only went up 1.6 on the Richter scale.